Good evening, class. Can you hear me?
Yes, like.
All right. All right. Uh, it, is it okay if everyone turn on your webcam so that I can see your face? Because today is our first encounter. It's good if you guys, some of you, can turn on your cams so I can see your face. Okay. What is this? All right. I see some of your face. All right. You can turn. If you feel that the internet is not good on your side, if it's good, you can turn on so that I can have, good interaction with you guys. So first, let me officially welcome you to our course, IE401, Apply Econometrics. My apology, as you guys know, I was infected with COVID-19. So you guys were requested to have some sort of readings by yourself the week before last week as your first lectures. So I request you guys to do some two reading. The first one was course syllabus. So you guys are expected to familiarize yourself with the course syllabus, with the grading criteria. How are you going to successfully pass this course? Okay, so this course, as you see the title, Apply Econometrics. So econometrics is a broad meaning. I am going to quickly recap what you're supposed to understand from the other week material. And also, I did review your homework, and I think I know what I should do a quick recap before we move to today's lecture. And as I know that some of you have already installed Stata, but some of you still have not installed it yet. For those who use Mac and you have already installed Stata, please share it with your Mac. Mine is licensed, so I don't know how to install or to download it from. So I tried to find a YouTube link to share with someone, but unfortunately it doesn't work. Okay, I apologize for that. So class, before we move on, as you can see on my share screen, some of you may know who they are right now, right? They are this year Nobel Prize awardee on economic science. So here they are. What I want to highlight from this Nobel Prize economy is that two of them, and Greece and Ambient, the two economists that I admire the most, I closely follow them. They win the Nobel Prize for their methodological contribution to analysis of causal relationship. Class, in the next few days, we will discuss about simple regression. Then we will highlight the concern of causal relationship. So econometrics, the main issue in econometrics, the main issue that you are going to learn in applied econometrics is causal relationship. And this middle guy is the author of one of the textbooks that I share with you. Okay, if you look at the textbook that I share with you guys in the folder, there are 3 textbooks, and one textbook entitled as the Mastering Metrics, and it was written by this author. Okay, so he won that Nobel Prize. Just to have a quick note that you guys now reading a book that is published and written by the Nobel Prize economist. Okay, Close that. And now feel free to turn off your cam if you feel if you feel uneasy with your camera on. But make sure you guys pay attention to me. I hope you guys listen to me. Okay. So from last week, not from last week, the week before last week, let's say from week 1, I requested you guys to do the reading on week 1 slide reading material. So you were expected to understand what is econometrics. So far, do you know what econometrics is? Why do we need to learn econometrics, apply econometrics? So econometrics statistical method to analyze economic data, but it is beyond statistical method. What is beyond statistical method? First, to proceed with econometric class, you need economic model. You remember the homework I asked you guys to read one of the 4 papers, and I asked you to answer what is economic model. So some of you, I would say, incorrectly answer these questions. Some of you refer econometric model as economic model. So economic model is not econometric model. Economic model is just like economic theory. Okay? So for instance, all right, if you want to understand the demand of a good, what should you analyze? What should you take into account? What factor that affects the demand of quantity? So you have to go back to the theory of demand from the microeconomics textbook. So what are the variables? What are the factors that affects quantity demanded? Price of good itself, price of substitute product, price of complementary product, many other factors. Okay, so when we refer to economic model, it's a sort of economic theory that highlight the factor that affects your variable of interest. I say this again. Economic model is a sort of economic theory. Okay, here if you look at this slide, class, you want to know what affect criminal activity. So based on theory, based on model, there are many other factors that affect criminal activity, such as wage of criminal activity, wage for legal employment, that's some sort of substitute, other income, probability of getting caught, probability of conviction if caught, expected sentence, the other factor as well. So here we refer to as economic model. Okay, not regressions. No, regression is not economic model. That is econometric model. Okay, so again, economic model is some sort of economic theory. Okay, if you want to know, for instance, the relationship between price of good and quantity demanded, you also need to include other factors based on the theory of demand. Okay, not simply only include the price of good and quantity of that good, but you also need to include other factors. Okay, you have to rely on economic model. So the question is, how do we know economic model? From your textbook, from literature review. Okay, so class, let me stress this. This course, Apply Econometrics, is just a section of research. In this econometrics, we focus on analysis. Okay, we focus on analysis. Okay, and from that economic model, then you try to use econometric, and econometric is what we are going to discuss for this course. But before econometric class, remember that you need economic model. And in this course, we are not going to discuss about economic model. You guys are expected to learn from the other courses, such as macroeconomics, microeconomic, principle of economic. You learn some various theory and models of economic. And for this course, we only focus on econometric model. Okay? Is that clear? What? Did you get what do we mean by economic model for now? Is that clear? Any questions?
Yes, sir.
Right. Good. So the other point that I want to recap is structure of data. Okay. From the written material, you should understand basically 4 types of data, but I want to focus only 3 types of data. Cross-sectional data sets. What is cross-sectional data set? It is the data from one time period. For instance, you conduct a survey. You conduct a survey with 100 respondents in 2020. That is we call cross-sectional data. Okay, it includes many sample of individual at only one time, or household, or firm, or city. Okay, at only one time. That is cross-sectional data set. And in our lecture, in this course, I think most of the part we discuss econometrics for cross-sectional data. In the last probably 4 weeks, we are going to discuss about panel data and time series. So again, cross-sectional data is a data set that you interview multiple individual, or you have data from multiple household, firm, or city, given only one time period. That is cross-sectional data sets. How about time series data? Same series data when you only look at once, let's say once respondent, or one place, or once unit. Okay, but you have data over time period. For instance, you have data for Cambodia for the last 30 years, so you can analyze that. Okay, that we call time series. You only have data for Cambodia for the last 30 years. That is the data. Okay, that we call time series. So cross-sectional, you have many respondents, only one time. But for time series, only one respondent, but multiple times. Okay, so different. Is that clear? And the last one that I want you guys know is not this poll. You can forget this. Panel or longitudinal data. What is panel or longitudinal data? It is the same as cross-sectional data, but it's over time. Meaning that now you have 100 respondents, but not only one time, you can have 2 or 3 time period. Okay, so panel or longitudinal data is a combined data set of cross-sectional data, or a combine of time series dimensions. Okay, so panel have a cross-sectional and time series dimension, multiple respondent, multiple time period. Let me say this again. Cross-sectional data, multiple respondent, one time period. Time series, one respondent, multiple time period. Panel combine both cross-sectional and time series dimensions. Is that clear, everyone?
Yes, sir. Yes, sir.
Right. So I stop here from the week 1 review. Guys, any clarification or questions? Please. Now, before we move to the next session, we are going to do some sort of statistic review.
Lecturer, would you mind explaining cross-sectional data again.
All right. Cross-sectional data is the data structure that consists multiple respondents, but with only one time period. For instance, you have data. Let me move back. All right. Here, if you look at this table, here is observation number, meaning when we say observation economy, we refer to we call it observation rather than respondent. Okay. So if you look at the row 1, meaning that you have first respondent. So here we have 526 respondents. Only one time period, but here we do not specify which time period. It means that you already conduct survey with 526 respondents. You collect data on wage, on education, experience, gender, and marital status. Do I answer your questions, Vari?
Yes, yes. Thank you, lecturer.
Is that clear?
Yes, very clear.
All right. So let me emphasize again. For cross-sectional data, multiple respondents with one time period, only one time period. All right. For time series data, here, one respondent or one unit, one city here, the data for one country or one city, but multiple time period from 1950 until 1987. So they have 38 years of data, but only for one city. That is time series. Okay, and for panel, it's just a combination of multiple cross-sectional or combination of time series. As long as you understand what is cross-sectional, time series, panel is just a multiple data set combining together. Don't worry. When it's come to data, I will tell you again. I will provide you the data set, and I will ask you guys what type of this data sets. Okay. So in short, I want you guys to understand what econometrics. So econometrics is you use statistical model to analyze economic data, but here to be considered as econometric, you need to start with economic model first. What do we mean by economic model? Economic theory. A simple, hypothesis or research question is, what is the relationship between education and earning? Is that really true that when you study more, you can get higher return on education? You get higher wage? Is that really true? If you go anywhere, if you discuss with yourself, you can argue. But as economists, as an economic student, you need to prove. Okay? We are economists. We need to prove. We need data to prove, not simply argue based on your opinion. Okay? Economists, we need to prove. We need statistical model. We need economic model. Then we need statistical model with econometric that they are going to discuss and then prove. Is that really true that when you study more, you earn higher wage? Yes. Udam.
So does this mean that econometrics it explain about economic model?
Right. That's correct. If it more on, yes, you already have economic model or economic theory, so we try to prove that. Okay, that's good point. All right. Before we move on to econometrics, course, apply econometrics in the next 2 weeks, you need to have some foundation in statistics. If you remember, you can refer to the syllabus. Prerequisite for this course is that you have some foundation in statistics and you have data installed on your PC. Class, this is applied econometrics, and I understand that many of you have not touched math or to mathematics in the last 2 years. So I will not spend most of my time on mathematical equations or mathematical formula or derivations, but I simply go to the point where you get this, and what that means and how to get the result from data application. So I will not spend much time on theoretical background from mathematical point of view, but I will try to give you guys the application and interpretation, because I understand that many of you do not have a strong background in mathematics. But again, we do need mathematics to understand this. Okay, so this week we are going to do a quick review on statistics, which you have learned from year 1. Any other question before I move to statistic review? No. If you have any question, feel free to raise your hands, or you can drop in the chat box. Interrupt me anytime. Don't delay. All right. So next, let's go to our introduction to the statistic review 1. And here it's going to be fundamental. It's very fundamental. Okay. Just to review what you have learned from year 1, and we go through together. All right. By the way, you can find the handout in the lecture note folder in the general channel. Okay. If I am fast, please do let me know. Sometimes I go too fast. Okay. So class, let's start our review on statistic 1. And after break, to relax your brain, we are going to do some hand-on exercise or introduction to data. All right. Let's move to review of statistic 1. So first of all, I want to review on measure of central tendency. What is central tendency? That's probably technical term, but it's simply we want to know descriptive statistics. Okay, so central tendency including means, median, and mode. And I believe that many of you are very clear on this. So just to review, so most of the time we don't say, mean, median, or mode. We simply call it central tendency. Okay, when we say central tendency, it includes these 3 statistics. All right. So here is a simple summary to know how to calculate mean, right? Means denoted by x bar is the summation of x divided by n. If you have x from 1 to n, median is just the middle value, right? And mode is the most frequency value. Okay, so here we don't call it mean itself. We call it arithmetic means or arithmetic average. And again, median is the midpoint of the range value, and mode is the most frequency of the value. This is just a quick summary. Next, we go into detail. So we start with means. So means, it is the most common measure of central tendency. And you need to remember this, class. Normally, we have mean for population and mean for sample. And I believe you know what is population, what is sample, right? So population is, if one understand population of Cambodian people, it's about 16 million now. For sample, you only conduct survey with a group of people among 16 million people. Okay, so for the means of population, it is written as mu equal xi from x equal 1 to n divided by n. Okay, so this is the mean for population. And for the mean of sample, the difference here is that we don't write it as mu. Mu is only for population. For sample, we write it as x bar. Okay, x bar. So x bar is equal, similarly, I equal 1 to n divided by n. Okay. So this is the difference only. The notation, yes, the notation is simply difference. All right. Next. So the most common measure of central tendency is mean. So it's simply in written is the sum of value, which is the summation sign here. The summation sign here, the sum of value. This is in mathematical expressions, and now written in the text, because the sum of value divided by number of value, right? So for instance here, let's calculate this mean. So we have how many? 1, 2, 3, 4. What is the mean? So the mean here we have 1 multiply 2, 3, 4, and 5, and divided by n. How many n? 5. So we have 15 divided by 5 equals 3. And for the second example, 1, 2, 3, 4 plus 10 divided by 5. So we have mean here equal 4. Following me? I'm going a little bit fast because I believe this is an easy for you guys. But if you cannot follow me, please stop me. Follow me? So this is the mean for the first sample. There are 5 respondents. And the first respondent have value 1, 2, 3, 4, 5. Summation, the sum of all the 5 divided by 5, we got 3. And this one, we got 4. And this is the arithmetic mean. So far so good? All right.
Teacher, so what does
Yep.
it mean by extreme values?
Pedants?
Extreme.
Okay, all right. Extreme value here meaning that or somehow we call outlier. So mean here, if you look at this value, in fact, if you look at 1, 2, 3, 4, 5, but the mean here is it's 3. But here, if you look at the second example here is that we have 5 respondents, but 4 respondents only have value 1, 2, 3, and 4. And only 1 respondent have value of 10. But when we generate mean equal 4. So it is affected by extreme value. What do we mean by extreme value? Meaning that a value which is quite larger than the other, which is seem to be abnormal. So if we look at this 5, mean should be somewhere here, but now because of we have tens as the outlier or extreme value, then we have mean which is 4, which is larger than the first group of sample. Is that clear?
Yeah,
so
teacher.
again, this mean is affected by extreme value. So normally we call it outlier. Outlier again is the data of a respondent which is seem to be abnormal and very different from the other. For instance, age. You conduct a research, okay? You target to ask students. So normally, if you ask year 1, they are around 20, but you have a respondent which age is around 30. So you treat it as an outlier or extreme value because you targeted student at year 1 and you expect them to have age around 20, but now you have a respondent with age is around 30 to 40, which seems to be an extreme value. And when you calculate or compute average age, then the average age seems to be high because of that one respondent. Right? Good. Next. Median. Median is simple. So median is in order list. The median is in the middle. Okay. So if we have only 5, so median is in the middle one. So we have, as you can see here, it's third. 1, 2, 3, 4, 5. So the middle ones. And if there are 5, and though they have the 10 and outlier here, you still have 3. So median is not like mean. It is not affected by extreme value. It's not affected by extreme value. Okay, so median is the middle value. What if you have This is in, you have 5 respondents. So what if you have 6 respondents? What should be the median value? Class, remember that. Here in our example, we have 5 respondents. So the middle one is treated as median. What if you have 6 respondents? How do we get the median value? Did you remember that? How to have a median value if you have 6 respondents?
Take 2 middle value plus together and divide by 2, teacher.
Right. Good. David. So class, here, because this is the quick review, we only highlight not all in detail. So if you have 6 respondents, for instance, the median should be the means of the 2 middle, okay? The means of the 2 middle respondents. So if you have 6 respondents, it should be the mean between the 3rd and 4th respondents. That's correct, David. Good points. Following me, class? Median. So when you calculate, it depends, class, whether to use median or mean. So the question is, for instance, okay, for instance, you guys are conducting a survey with a group of students. Group of students is normally it's okay. But if you conduct a survey with consumer, okay, the question is, what is the appropriate age to refer to? Are you going to use mean or are you going to use median? So normally the commonly used we use mean, but if there are an outlier, we tend to use median. Why? As you see here, median is not affected by extreme value or called outlier. Right? Next, mode. Mode is the value that occur most often. It also not affected by extreme value. It's used for both numerical and categorical data. For mean and median, we only use for numerical data. I hope you guys know what do I mean by numerical and categorical data. Okay, so categorical data is the qualitative data. Numerical data is the quantitative data. Age, income, categorical, gender, boy, girl. Okay, so for mean and median only used for numerical data, but for mode it can be used for both numerical or categorical data. At some time, probably there are no mode because every value only take one value. Okay, there are many several modes as well in some cases. Here, if you look at the first example, what is the mode? Mode is 9. Why? Because 9 has 3 respondents, 3 frequencies. But if you look at second example, no mode at all. Why? Because every value except 4 has one frequency, has one count, has one vote. Okay, but for the first example, 9 has the highest vote. So 9 is the mode among the other number. Again, there may be some example that there are no mode, but at the other example, there may be several modes. For instance, at some point, if numbers of n vote for 5, then we have 2 modes. We have mode 5 and mode 9. If only if 7 here is go to 5. So we'll have 3 for 5, 3 for 9, then we have 2 modes, right? Any questions about means, median, and mode? In short, we call central tendency. I try to find a slide with this, visually or graphically easier to understand for you guys. Not too much math. Not too much, but it doesn't mean that it does not have. Okay, not too much, but you still need math. You cannot study without math for econometrics. All right. Next, which is the best locations? Which measure of location is the best? Should we use mean, or should we use median, or should we use mode? As I told you earlier, and if you read many articles, I believe that up to now you guys are here for and you read a lot of paper, reports, book, and most of research they use mean, they report mean. Mean is generally used unless extreme value outlier exists. But in report, no one tells you there are an outlier in their research. So they oftenly report mean. I myself also oftenly report mean. We rarely report median. Why? Because we want to know average income rather than median income, right? So median is often used since median is not sensitive to extreme value. So most of the case, if there are some extreme value, again, what is extreme value? Outlier. The value that seem to be abnormal than the other. I give you an example of age. So, you expect age of respondent is around 20, but when you have one respondent age is 30 or 40, that we call it extreme value or outlier. Okay, so median is used when there are an outlier or extreme value in your data. Example, median income, a median home price may be reported for region because it is less sensitive to outlier. So it depends on nature of your data. If your nature of data have an outlier, it's better to report median rather than mean. All right, this is all for central tendency. Questions?
Yes, yeah. So about mode, teacher. Can you move to the mode slide?
Yep.
Sure. So there is only one case that there is no mode, right, teacher? When all value has the same frequency.
Right. Only one case when all value have the same frequency.
Yes, teacher.
Right.
Sure.
Right. If any other value have more than the other, then we will have multiple mode. Either one mode or multiple mode. Okay. So only one case when there is no frequency is that every value have the same modes. Good point. Good summary. All right. Next, we discuss about measure of variability. So first we discuss about sort of descriptive statistics. Now we look at variability. When you look at mean, you look at mode, you look at median, you do not know variability. What do we mean by variability? Variability is the measure of variation given the information on the split of variability of your data. For instance, you have data on age of respondent, but you want to know what is the variation among your respondent. What is the oldest? Who is the oldest? What is the oldest age? What is the youngest age? How far is it from the mean? So you want to know the variation, the range among your data. Okay, so we need to discuss about variability. So in literature, to know about variation of data, there are some statistics that you have to study: range, interquartile range, variance, standard deviation, coefficient of variation. In this review, I am going to review some of the importance or often used method, which is connected to our econometrics. Okay, so next we discuss about range. What is range? Range is very simple. Range is the simplest measure of variation. It is the difference between largest and smallest observation. And again, you see, statistics and econometrics we call observation. When we say observation, if you have 10 respondents, the first to the 10 we call it observation. All right. So range is just equal the largest value minus the smallest value. In this example, it is, for instance, you have ones, vote for one vote for 3, 2 vote for 5, blah, 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 blah. But at least you know that the lowest is 1 the highest is 4. So range is simple. It's just the highest minus the lowest. You do not take into account the variation among the data itself. You do not take into account, oh, there are 3 votes for 9. No. Range simply 14, the highest, minus 1 equals 13. This is the range of the data. So if you have data on age, simply use the oldest age minus the youngest age. So you see the range of your respondent age. Okay, very simple. That is range. Next, as you see, range is very simple. However, range itself ignores the way in which data are distributed. As I said, if, for instance, if you look at the first example again, for instance, you have 1 for 7, 1 for 8, 9, 10, 11, and 12. So range is just 12 minus 7 equals 4. But for second example, you have 1 vote for 7, but you have 3 votes for 12. But range only use 12 minus 7. So it does not take into account the distribution of the data. What do I mean by distribution of the data? Here 12 have 3 votes, but 7 only have 1 vote. So range failed to take into account the data distributions. So it is sensitive to outlier. What if our data, as I said, earlier, that your respondent age you expected to have around 20, but someone else have their age is about 40, then you will have a high range of respondent age, which seems not to be true. Okay, so in this case, range is not oftenly used, but it is good to know it. Okay, here, if you look at this specific example, the first example, you not see any outlier. So assuming that 1, 1, 1, 1, 1, 1, you ask about something 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 4, and 5, and range is 4. But you ask another group of people, they start on 1, 1, 2, 2, 2, 3, 3, 3, 4, and then another one say, I have 120. Okay, so here we have extreme value, and the range here is 100, 119. If you look at data, it should not be, right? Because most of value is 1, 1, 2, 2, 2, and 3, and now you have range is 119. It seems to be wrong. So normally range is not often used to understand the variation of your data, to understand the variability of your data. Okay, so normally we study variance. So variance is a statistic that we use to understand the variation of the data. And how to calculate variance? Variance is the average of square deviation of value from the mean. Okay, as I said, I do not go into detail, it's just a summary. So I expect you guys know how to calculate variance. So if you don't understand that, please do a quick review from year 1. So variance is simple, it's written as delta square. It equals here, you have x value minus mu. Mu is the mean square, and this is just a summation. In the sum of all observation, the value minus mean square, and summation all of the observation divided by x. Okay, again, mu here is the population mean, n is the population size, and x is the value of the variable x. For instance, age or what. So if you have respondent age, here is the individual respondent age, and mu is the mean that we discussed at the beginning, and n is the number of population size or the number of observations. Can you guys follow me with this mathematical equations? And variance, you will see it very often in econometrics lecture. Variance, covariance, correlations. So if you don't familiar with it, please try to understand this. Try to recall back how you calculate variance. Questions? All right, let's have a look at example. Oh, sorry. So this is the variant for population. Class, just have a look. It's just one is population, and another one we are going to talk about the sample variant. So here you have a look at mu. This is mean for population, and delta here is mean for the population variant. For sample variant, we have S as the S square as the sample variant, and instead of mu we have X bar. X bar is the mean of sample size. But instead of divided by n, for sample variant we divided by n minus 1. Okay, take note the difference between population variant and sample variant. Okay, the difference is notations and denominator. For denominator of population variant is n. Denominator for sample is n minus 1. Is that all right? Okay, we move next. All right. So variant is not the ultimate goal that we want to generate. We simply want to generate what we call standard deviation. What is standard deviation? Standard deviation is the most commonly used measure of variations. It shows the variance about mean. How far is it from mean? It has the same unit as original data. So population standard deviation is just a square root of variance. If you know how to calculate variance, so delta square is variance. So population standard deviation is just square root of variance. Then we get this standard deviation. So standard deviation of population, this is delta. Follow me? And for the sample standard deviation, it's just square root of S square. Now we have S. Okay? So if you know this back here, it's just a square root of this one. Square root of this one. Okay? So let's have a look at the example. Remember the formulations. So assuming that you have, this is respondent A, you have 2, 4, 6, 8 respondent. The first respondent age is 10, 12, 14, 15, 17, 18, 16, and 29. So now you have an observation, and you can calculate yourself that mean equals 16. How to generate mean? To compute mean? Sum of this all value divided by age. Then you will get 16. Okay? So based on this data, we have n equal 8, mean equal 16. Okay? To calculate sample standard deviation S, you remember the value divided by minus X bar. So here we have 10 minus X bar square plus 12 minus X bar square, and so on. Okay? And divided by n minus 1. So we have 10 minus 16, 8 divided by 1. So you get sample standard deviation is this. 4.24. Take a minute and have a look at this computations. Can you follow it? Class, how is it? When it comes to data in the next session after break, we will do some descriptive statistics, and then you will know You can calculate the standard deviation very easy. Mean, standard deviations.
Teacher,
Yep.
what does the result tell for point?
Here?
Yeah.
Okay. So here a measure of average scatter around meaning that now assuming that this is the respondent age. So the respondent age on average is about 16 years old. And the variation about your data is that on average, the respondent age is about 4 plus or minus to the mean. On average, you know what I mean? So it means that now the mean of the respondent age is 16. The data tell you that your the variation is around plus or minus 424. You will see another example. We compare the standard deviation based on an outlier. Here, it may not a complete picture, but in the next slide, you will see it, Nick, don't worry. It's hard to understand my interpretation. Is it? So here, it again, average scatter around mean, meaning that now you have mean here, it's 16, okay? So on average, it scatter around 4 years, 4.24 year around mean, your data, okay? On average, your data on mean age of respondent is 16 years. On average, it is around 4 years of the respondent age. You get what I mean?
Yes, sir.
Okay, it scatter around the 16 here is about 4 years from the mean age. So it scatter around this. The range here is around 16 plus minus 4. Okay? Class, can you follow these calculations? Okay. So just take note yourself. What is the formulation of variance? What is the formulation of standard deviation? You will see it again during our econometrics lecture. As I said, I am not going to, to discuss much about math, but I am going to tell you what does that mean and how to calculate its data and how to interpret it. Questions?
Teacher, so during midterm or final exam, we still have to do calculation by hand, right?
No. Don't worry. Apply econometrics in my course. I want you guys to do the project, and I will not have an example, question on calculation, but you are more requested to work on your project. I will ask you if you want to assess the relationship between this and that, how do you get the best estimate? What is the practical issue should you address? Don't worry, you will learn from the quiz. Familiarize yourself with the quiz. Is that clear? Don't worry, class. I am not here to kill you. I am here to help you to to familiar with econometrics, apply econometrics. I understand that many of you do not have a background in statistics for the last 2 years. Am I correct, right? For the last 2 years, you do not study any math subjects.
Yes, lecturer.
All right. Any question? Can you follow these computations? Just try to follow this step first. Are you following me? Yes or no?
Yes, lecturer.
Thank you. All right, next class. So here is an example how we calculate standard deviation. So as I said, here on average, the respondent age is 16 years old. And your data tell us that based on the standard deviations, the data is scattered around 4 years around mean, meaning that most of your respondent is between 16 minus 4 is around 12 years old to 20 years old, right? So as you look at the data now 12 to 20, what I mean here is plus or minus 4 standard deviation. Don't worry, step by step. Next, here. So what it says here is that class, when you have standard deviations, here we have standard deviation equal 424. When you have small standard deviations, your data look like this, small standard deviation, meaning that your data is close to the mean. So the middle, the dashed line here is the mean value. So the small standard deviations, meaning that your data is close to mean. You do not have much error with an outlier. But if you have large standard deviation, your data is look like the below curve. It's scattered. A wide range of data. You understand what I mean? So for instance, if we look at our example, assuming the middle line here is 16 years, okay? So the distance from the mean here is around 4 years, okay? At around 4 years. The distance from this dashed line here. So meaning that this is a good variation. All right? Huh? Yes or no?
Sure, I have one question.
Yep.
So why do we want to calculate the sample standard deviation?
We want to know the variation of data. As I said, for instance, if you target a group of people, for instance, our example is respondent A, you know what is going on with your data. If your data makes sense or it is somehow incorrect. Okay. If you look at it, for instance, if you have a small data set, it's okay. You can go one by one. But for instance, in my case, I analyze around 10,000 or 20,000. So I cannot simply look at observation individually. Then you have to look at standard deviation to know how good your data is. Where is the variation? Is it close to the mean or far from the mean? Do we answer your question, Kim Hua?
Yes, not sure.
Don't worry. I believe that you need some experience first to make sense of this. All right? You will get more idea when you work on your project. Let's move next. All right, here, to understand more about the data, okay? So we have 3 example data A. You see, class, data A, here you have a variation that you have, the smallest is 11, 12, 13, 16, up to 21. Data B, it's centered around 14, 15, 16, or 17. Data C, it's more on 11, more on 20. Here, if you look at the mean, okay, means is the same. Mean is the same. You know how to calculate mean, right? Sum all the value divided by n. Standard deviations, you have to go back, x value divided by mean square plus all the other divided by n minus 1. Here, if you look at here, you see the data A has more variation. Means the same as data B and C, but if you look at standard deviation, it's a little bit high. 3.3. For data B, the same mean, but standard deviation quite low. Why? It's centered around mean. Mean is 15. So when you have very small data, it means that your data is centered around this. So I hope this example can somehow answer Kim Hua's question earlier with this visual graph. Okay, if you look at data C, we have more data on 11, we have more data on 20 at the lowest, at the highest. Then we have higher standard deviation. So it tells you can see, if you look at just only standard deviation, you can understand the variation of your data. If, for instance, you target only first year student as your respondent, there's something wrong with data C. There's something wrong with data A, but data B may be correct because something centered around the mean. Kim Hua, would it somehow answer your earlier question by looking at this visualized graph? Right. So with this graph, you can see it clearly, but in fact, if you look at the standard deviation, you can tell itself, right? You can tell. So the higher standard deviation, the large variation. So the low standard deviation is close to the middle. The data is almost homogeneous. All right, can you follow me, everyone? By now, we just finished variance and standard deviation. And variance is just the square of standard deviation. Standard deviation just the square root of variance. Both are just the same procedure. We compute variance in order to understand standard deviations. I try to explain you guys in a simple word, not a technical word.
Teacher.
Oh, yep.
So how can we tell when the standard deviation is small or high?
It depends on unit of. It depends on the variable that you are looking at, and it depends on the standard deviation itself. For instance, if you look at income, okay, if your data is on income in dollar or in real, so you can know if, for instance, if the standard deviation is 100 USD, is that high or low? Okay, you have to compare it with mean. For instance, here if this is income, so we have see that the average income is 15 and standard deviation is $3. Is it high or low for your understanding? So $3 comparing to $15 is still high. It's around 3 divided by 15. Next we will discuss about TV. You will see in percentage later. Okay, so it depends on the variable itself, the measurement. Is it an income? And then you have to compare with mean. Do you understand do I answer your questions?
Yes, sir.
Okay, so you look at the mean here. The mean is 15. If it is an income, it is still low, but standard deviation 3 to 5, 3 to 15 is still high, right? If here 15 and 4 is still high. But don't worry, it does not tell that your data is wrong. It just tells you that you have high variation. Data C have very high variation. Data B is not high. Okay, it probably depends on your design, your study design. That you want to, for instance, if you want to collect data on income, you may collect some data from employee and some data from boss. So that is why you have high variation. It depends on your nature as well. So again, it doesn't tell that your data is wrong. It only tells the variation of the data. Variation of the data. Okay. All right. Both we finish variance and standard deviations. Next, I don't know if I can finish this. We talk about coefficient of variation. When we discuss about variance and standard deviation, the unit the unit itself is depend on the measurement of the variable. Okay, for instance here, if it is age, the unit is age, both mean and standard deviations. If this is income in real, the unit is income or real. So you cannot compare it with other variable. For instance, if you have one variation, one variable, you ask about age, another variable you ask about income, then you cannot compare the variation between the two variables. So the best way is to measure coefficient of variation. What is coefficient of variation? It still measures the variation itself, but different type of analysis. So it measures relative variation. So now it measures relative. When you say relative itself, it refers to percentage. Okay, it relative to some things. So it's always in percentage. It's always in percentage. Unlike standard deviation, the unit, it depends on the measurement of the variable. Let me say this again. Standard deviation, the unit is depend on measurement of the variable. If it is age, it is in year, standard deviation measure in year. But CV, which is coefficient of variation, always in percentage. Okay, always in percentage. So it's all variations related to mean. Okay, how much in percentage? How far is it to mean in percentage? It can be used to compare two or more sets of data measured in different units. You see, you can compare it, the variation between income and age. But for standard deviation, you cannot compare between income and age. But for CV, you can compare it. How to calculate it? Standard deviation divided by mean, multiplied by 100%. Okay, very simple. It's very systematic. First, you need to understand variance to calculate standard deviation. When you know standard deviation, you can calculate coefficient of variation. Okay. Next, for instance, here, stock A, the average price is 50, standard deviation is 5, then you have variation equal 10%. But the problem is that you have to calculate standard deviation. Okay. Stock B, price last year is 100, standard deviation is 5, so 5% as well. So both stock have the same standard, but stock B is less variable related to its price. You see, you need to understand to compare to mean. How far is it from mean? So it is 5% from mean. This is 5% to 50. So if you do not have this CV, which is measured in percentage, here you will look at, oh, this is why your question you ask me whether this is why is large or small. 5 compared to 500. So it is subject to your own interpretation. I don't remember someone that asked me earlier. I don't remember your name. So you asked me whether this standard deviation is high or low. So I told you that you should compare it to the mean, right? But now CV do it for you. CV does it for you. So it measures in percentage. Okay, 5 to 50, it is about 10%. So 10% is already high. But here, 5 to 100, it is 5%. So rather than use standard deviation, it is good to use CV to understand variation of your data. So it tells you that the data is centered around 5%, 5% around your mean. This is 10% around mean. Okay. Who asked the question earlier about
it was
standard? Yes, Samna.
yes.
Was that you, right? Right.
Yes.
So Samna, I hope that this CV could help you to have a better understanding about standard deviation.
Yes, sir, it's clearer than before.
So earlier, if you compare, I don't know whether the standard deviation 5 here is large or small. But if you use CV, you know that, oh, this is 10%. So simply 5 divided by 50. All right. So far we discussed variance, standard deviations, and now CV. Not curriculum vitae, but coefficient of variations. Class, how are you? Questions? You have no choice, class. You cannot avoid math with econometrics. As I told you, I try my best not to use too much math. Question, class? Questions? How are you?
No question, sir.
All right. Thank you, Robin. All right. Move next. So here what we discussed so far is variance, we discussed mean, we discussed standard deviation, and we discussed coefficient. Here, you need to understand here, based on standard deviation and based on many studies, they formulate a rule. Okay? They have an empirical rule. What is that rule? The rule is that if data distribution is approximately binomial distribution, meaning that it's very simple, it's around mean. So if your data is normally distributed, all right, so with mean multiplied multiply or minus 1 plus standard deviations, it should contain about 68% of the value. What it says here is that if you interview 100 respondents, and if you have a very good data with normally distributed, when we say normally distributed, it should follow this curve, okay? And what that means is that normally mu plus or minus 1 multiplied by standard deviation should account for 68% of your 100 sample. You got what I mean? So you need to understand this standard deviations. Mu plus or minus standard deviations contain about 68% of your data, of your 100 data. If you remember earlier, I tried to interpret that the standard deviation tells you how far is it from mean. So if standard deviation plus mean, it should contain around 68% of your data. Here is only plus 1 standard deviation. If it plus or minus 2 standard deviation, it means that 95% of your data is between mean plus 2 standard deviation. If 3 standard deviation, it contains almost 100. It already 99.7 data is in this range between mu minus 3 standard deviation or mu plus 3 standard deviations. Follow me? Have you seen this before?
Sure. What if mu plus 2 standard deviation is less than 95%? What happened?
No. This is not what happened. This is based on empirical rule. What it means is that when they conduct many studies with a large sample set, they found this. This is the rule that they found. So normally, if your data is good enough, normally distributed, when we say normally distributed, meaning that if it is closer to the mean, you have more sample. Okay, you have more sample, and when you are far from the mean, you have less and less sample. It should be the same as this rule. If it is not follow this rule, it's okay. But this is just what they found, and they just want to tell you what is empirical rule is. If your data is normally distributed. Got it?
How can we actually apply this? Yes, lecturer. So how can we actually apply this rule to our data in our research?
This here is you don't have to apply it, but here what they want to say here is that if you found that, for instance, you calculate mu and then you can calculate standard deviations, and when you found that if your data have 95% located between this mu plus 2 or minus 2 standard deviation, meaning that your data is normally distributed. When we say normally distributed, the curve is look like this. It is not skew on the left or skew on the right. When I say skew on the left, meaning that the highest curve here not in the middle, maybe on the left, or the highest curve here maybe on the right, if it is not normally distributed. So it means that your data is good one. Do we answer your question, Kim Hua?
Okay, lecturer. Yes.
Okay, so what we want to say is that based on empirical rule, if your data is centered around this mu plus minus standard deviation, meaning that you have a good data. What it says that the variation of data is very good, very normal distributed. And in statistics, this is not to mention, but just to let you know, if your data is not normally distributed, you have a lot of problems that you have to deal with. But I don't want to scare you because I'm afraid that is out of topic. Okay, so it's better if you have the data, meaning that your econometric exercise can follow what we call standard assumptions. You will learn it next. Okay, so hopefully your data, my data, every researcher data is located in this range, mu plus or minus this. Okay, so if they are outside this, It means that you do not have, again, I would say again, if it is not the same like this empirical rule, meaning that it is not normally distributed. If it is not normally distributed, it means that the curve here is not highest in the middle, but the highest is maybe on the left, or the highest is on the right. Okay, that's what it says. Have you seen this before, everyone? The distribution of plus minus, or you don't remember probably?
I never see this before, lecturer.
All right. But if you started before, you should have seen this before. I'm very sure. No, go ahead.
Yes, lecturer. And how can we actually know that our data stay in this rule?
Okay, so you simply calculate mean and calculate standard deviations. Okay, simply calculate mean and standard deviations, and then look at your data if it is correct or not. Now we will have an exercise on this. Okay, let's move next to look at the exercise. Okay, assuming in 1 year the average stock price of good gold was 800. Okay, average price meaning this is the mean. Okay, mean value with standard deviation equal to $100. So in what interval approximately 95% of the stock price would be? So here you can know the interval of your 95%. What would it be? How to calculate this? Remember the rule? 95% mu plus minus 2 standard deviations. So what we have to do is, anyone guess what is the correct answer, A, B, or C? If you look at the slide, you will know the answer. A, B, or C?
C.
Here. B?
Yes, sir.
So this is, we have mean. Mean is 800 and standard deviation is 10. So if it is 95%, it means that it's 2 mu plus or minus 2 standard deviation, right? So 2 multiply 100, 800 minus 2 plus or minus 100. So let's have a look here. What I'm saying, I'm afraid that you do not follow me. So because mu plus 2 standard deviation contain about 95% of the value, so the interval should be this: 800 plus or minus 2 multiply 100, right? So 800 minus 200 and 800 minus 200. So the answer is B, correct. Okay, so now your 95% should be between 600 to 1,000. So based on this, you know the range of your data. Okay, so simply calculate mean and standard deviation. You know that 95% of your data is between 600 to 1,000. Follow me, Kim Hua, everyone?
Yes, lecturer.
Okay, so you know that the stock data that you have now is 95% out of 100 is between 600 to 1,000. Okay, we simply can do that. All right, we have about 7 slides to go. So let me have a look here, but I don't think that much. Weight mean, I believe that everyone already know what is weight mean. We earlier discussed about mean, now we discuss about weight mean. You know what weight mean is, right, everyone? So when it comes to mean, it's summation divided by n. But for weight mean, it is the value multiplied by weight. It may be a little bit difficult, not easy to understand this, but it's good to look at this example. Okay, it's just like my grading criteria. You look at my grading criteria. That grading criteria is also considered as range. Okay, in total, it is 100%. But how much I allocated to quiz, how much I allocated to assignment, how much I allocated to midterm, how much I allocated to the final. So here, consider a student with score of assignment X1. Score of assignment is X1, clicker X2, midterm X3, and final is X4. Okay, and X1 is equal 100, X2 equal 0, X4 equal 90, and sorry, x3 equal 90, x4 equal 70, the weight, okay? Assignment, 20%. And then x2 is midterm, 5%. The clicker, 5%. The midterm, 30%, and final exam is 45%. And how to calculate wage min? It's simply wage multiplied by value itself. So here we have 2 multiplied by 100 equal 20. 0 multiplied by 0.05 equals 0. 90 multiplied by 0.3, 27. 70 multiplied by 45% equals 31. So totally, the score here is 78.5. That's what we mean by wage min. Follow me, everyone. This is how to calculate the score. How we calculate the score. That is wage min. Guys, are you sleeping? I'll play again. How are you, everyone?
Hello, lecturer. So
Yep.
for the weight, here, do we have to calculate it, or they are given?
Weight here is normally is it depends. It depends on the exercise. So for instance, if this is the assignments, this is about the course. So the weight here, I am the one who give it. Okay, and normally it add up to 100%. It depends on the exercise itself. Okay, normally it is given. In my case, I am the one who give the weight, but in the other exercise, probably you have to calculate it. It depends on a real example. Is that clear, Kim Hua?
And how can we actually calculate the weight?
There are many examples. There are many ways, but here we don't. Here we do not intend to discuss more on how to calculate weight. So you will take the weight as given for your exercise. Okay. To be short, I cannot. It's gonna take time to answer your question. That's a good question, but here we do not intend to discuss how to calculate weight. Okay. So the exercise that you have normally you have to calculate based on given weight. In short, is that all right, Kim Hua? There are
Yes,
many ways to calculate weight, but our review here is not to discuss on weight, and the means the weight mean here is not what concern in our course, but I just want to highlight it. All right, class. So let me finish it before our break. So no, if it's already 7, let's continue later after break. Now I believe that your brain is burning, so I will finish the last 5 slides at the end of today's lecture. Let's do some hand-on exercise after break. So class, when I was with the other class, I was informed that normally you have 20-minute break. Is that correct?
Yes, sir.
Some 20, some 30, teacher.
And do we also extend our time, or we still finish by 8:30?
Some class finish 8,
8:30.
So we still finish by 8:30, correct, right? But I mean
Yes.
that when we have break for 20 minutes, so do I have to add on to finish class by 8:50? I just want to clarify.
No, you don't need to do that.
all right. I just want to know the norm, the practice. All right, thank you, class. So now it is 7:01. You have 20-minute break. Please return back to the room at 7:21. The 20-minute break start now. Hello, everyone. Are you back in the room?
Yes, teacher.
Okay, class. As I said, after break, let's move on to some hand-on exercise. So we are going to talk about Stata. So for those who have not installed Stata on your PC yet, please try to get one. As I reply in comment to Kim Hua, I have not done any installation before using that unlicensed software. Mine is license one from my private university. So as you can see in the screen, this is how it looked like. So class, again, if you have installed Stata on your PC, either Windows or Mac, please try to have your mate. If you have installed Stata on your Windows, try to assist the other that have not have their Stata installed on Windows yet. And for those who have installed your Stata on your Mac, please help to share it with your classmate as well. So my apology for this week. I am going to introduce you to Stata. And for those who do not have Stata, my apology, but you have to just looking at the screen and follow us. For those who have Stata, please try to follow me. And for those who don't have Stata, don't worry, you can still follow this slide. The slide is very easy. You can follow it step by step. But what I'm going to do today is to not to go into the detail, but pick some main point to do it. Okay. So for those who have Stata, please use open your Stata, and we can go together now. To make sure you have installed it, as I said, the latest version now is 17, but any version is fine. Mine is 15, not the latest one. It is, I cannot have the latest one. Okay. So please turn on open your Stata applications, and this is how it should look like. May I ask how many of you have not installed your Stata on your PC? Can you raise your hand so that I can know approximately how many of you? Just raise your hand so that I can see the number. So 7, so it's about 12 students. Everyone, are you here? If you have not have Stata installed your PC, can you raise your hands? All right, and about 12 students have not installed your data yet. Please, everyone, try to ask your classmate for those who have installed. Please help them. I will also try to find another video or link or tutorial where you guys can have a version of your data. Okay, now you can, stop raising your hands and we can move on to our data applications. All right. So, introduction to data. First of all, why I want to introduce you guys to data. There are many software for the statistician, but as I know, most applied econometricians use data. There are several reasons, but one of them here is that data is that there is a journal where you can you can get up-to-date information what is going on with data. For instance, I myself, because I have a license software, I used to purchase it. So I always get update information what is going on to the current developments and what is going on to the new code, new command when they develop any new coding. Okay, so it's just like an academic field that you know what is going on. So they have a data, like they have a data journal. Now let me show you here. I type data journals. So there is an publishers publish this data journal. Okay, any command, so on. So that is one important field. And second, one of the famous university in US, UCLA. I forgot the full names. They are the one who are responding for, disseminating the sharing the data like here. You can find many other useful. I will share you other necessary informations and material regarding to data. But I believe that if you closely follow this slide class, you learn a lot from this. And another reason that I want you guys to learn data is that if you have to do it multiple times, if you have to do statistical analysis multiple times, you don't have to do it again and again. I want to introduce you guys to learn how to write some sort of command or what we call programming step by step. Don't worry, not complicated. I will introduce you the easy one. Okay, so this is the two reasons, but why I want to introduce you guys to data. Right now, class, more and more people start to use R, or we call OR software, if you have heard about this. But not many economists use it yet. R is good for data science, for visualization. So just for your information. All right. So let's go to data. Okay. So here's how it looks like. I don't have to go into detail. This is the first one here, the bottom one here we call command window. Okay, this is command window where you can type in any command. We call it command. We don't call it code. Okay, command. For instance, can you see my share screen, everyone? Just to confirm. Can you see my entire screen here? All right. Yes. So below here we call it command window, where you can type. As you can see here, command, you can type anything. If it is wrong, shape here. It tells me that command shape is not recognized, so it is not correct. Okay, but if I type clear, meaning that I want to clear data, don't worry, it's just step by step. I want to clear data, nothing wrong. Okay, meaning that clear is the correct command. So when you get it wrong, you will see that command shape here is unrecognized. You will see the response. They tell you that there's something wrong with here. Okay, so this is we call command window. Next, another one is we call on the right hand side we call variable window. There is my data. Okay, on the right hand side here, but right now we do not have variable yet. because I do not loading any data yet. But just to tell you, this is, as you can see here, the term variable. This is variable window, and here we call result window. As you can see, the term result here. This when you write anything, it will appear on the script. Okay, this is for command. This is to show you the variable, and this is the result. Just familiar with interface first. All right. So here I move next. Follow the slide step by step. All right. In fact, there are another window, but I don't like it. Personally, I don't like it, but I can show you. We call it review window. For instance, I click review here. If you go to window, by the way, class, mine is Mac versions. So it may be a little bit difficult, a little bit different from those who are using PC. All right, if I click review, you see a new window here. A new window here allow me to edit code that I write wrong. For instance, earlier I wrote Cape Hyun, right? So I click Cape Hyun here, then it appears again. So I can edit it, okay? I did it as, no, I don't want Cape Hyun, I want Hyun 1. It is wrong again. So I can click it and edit again. So this review allow me to edit what I wrote wrong earlier. Okay. But again, as I said, normally you will know why I don't use it, because we use do for. Later you will know what is do for. So I don't like this review because I want the entire script. All right. Any questions? Why now? So far so good.
Sure, is data case sensitive, sir?
Yes, data is case sensitive. When we say case sensitive, meaning that normally the variable that you use is better to have a always lower case. And data does not allow space. Variable name, it does not allow you to have space. For instance, if you want to say what is that? Year of schooling. You cannot type year of schooling as the variable. What you can do is you can type year underscore of underscore schooling if you want to have variable name as year of schooling. So normally it's better not to have, not because this is the variable name. Don't worry, what I want to say here is case sensitive. So it's better to always use lowercase so that you don't have to worry about whether this is the variable name is wrong, right or wrong. If you have to use, uppercase. All right. Next, working directory. You need to know where is your working directory. Working directory is a location, is a place where all your data will store. Okay. If you look at mine, my working directory is in here, Royal University of Phnom Penh's research project, blah blah blah. Okay, so I can change that. So you can change it manually. You can go to where's that? Let me have a look. Okay, file, and here you can change your working directory manually. Okay, you click change, and then you can go to the place that you want to choose. So for instance, now I want to choose it as, where is it? The teaching material, and I want to store it now in data. All right, choose. And now if you look at my working directory now, you can see it is blah blah blah, OneDrive, Royal University of Phnom Penh, teaching materials data. So every data that I'm going to store in the future is gonna store in this folder. You can find, you can change yours as well. Following me? Were you able to change your working directory? Any problem? Are you clear with working directory, everyone?
Yes, sir.
Questions? Good. So remember, in the future, if you do not know where to store your data, it's always go to your working directory. Okay, your working directory. Next, data menu. All right. So this is what I told you earlier is that one of the reason that I want you to learn data is that you don't have to do it manually. But it doesn't mean that you cannot do it manually. Okay. For instance, here you see a lot of options. Data, graph, statistics, so you can analyze many summary data. Okay. I will tell you later that if you don't know the code, you can start with, by using the manual click, and later you can copy and paste the code, and then next time you don't have to do this again because it takes time. It takes time. All right. So, but what I'm going to say, what I want to say is that it doesn't mean that you cannot do it manually. You can do it manually. All right. But you need to understand option by option. Okay. Next, do file. This is the important point that I want to highlight for you today. What is do file? So do file, start do file, add a text file where user can store, can run their command. As I said earlier, command here means code, but we don't say it is code instead. We call it commands for reuse. You can work in the future rather than retyping command on command window. Okay, what we are saying here is that rather than come at the command window, you have to come back and do it again. So what you have to do here, if you look at my screen, you see an icon called do file editor. Can you see that? You click it, then you have a new interface that is do file window. Okay, and every time if you want to run it, you can run. For instance, I type clear. So when in my do file, when if you see it clear in say red color, so if I want to run it class, I just select it and then I click do. It clear. So it clear. If I want to, for instance, run the change directory, rather than do manually, I just copy the command here. It's CD, copy, paste, and then I just click CD here. It's mean that it's the same as what I did earlier. Okay. So now still in data folder. All right. And then you can click save this do file for future use. Then I save it in data because our working directory, my working directory is in data. So it automatically direct me to the working directory. So I click save. So for instance, now is this intro to data, and that is for IE401. Okay. So I save it. This is the file, the do file. So next time I don't have to come here again. So I just do it here. Follow me, class. So do file is very important. Every time you work on it and you want to run it again, just click and click run. You don't have to go here to change directory, click manually. No, you don't have to write it manually on this command window. Do it again. You just work on the do file, and then you can work from do file and click do. It works the same way as either you manually click it or you copy the code and run it in this command window. It's the same. But do file saves a lot of time. Follow me, everyone. Questions? Am I fast? Or is that okay? Can you hear me?
Yes, sir. We can hear you, sir.
Okay. Class, can you follow me? We have not started any yet, just to introduce you to the interface and do file. Questions?
No, sir.
Okay. So next. Okay. So here on the slide suggested, we recommend always use do file when using Stata. And remember, the Stata do file extension is .do. If I come back here to my folder, look at my file, it is Stata, and then file name is do. The extensions here is .do. All right. lost the connection with my earphone. Let me change this. Can you hear me now? I changed the earphone. My earphone. Can you hear me?
Yes, sir. Yes, sir.
Oh,
yes.
thank you. Thank you. Thank you. All right. So always use do for. So next we are going to do some, exercise, display, and then always work with do for. Remember that. All right. So here is the do for those who are using Windows. You can find this. Class, let me confirm this. Can you find do for icon on your PC, on your data? If you cannot find it, please do let me know. Okay. Hopefully you can find it. All right. So you're gonna have something like this soon. All right. I already show you. All right. So let's play with some data. Not this one. All right. So now, given that you use data, I'm not quite sure if you can do this, but I believe that you can do this. Here on slide 24, as I said, guys, you had access to this file in the folder. So you can just copy this. Okay. You can load data over internet. So I copy this. And I load the data from internet. As you can see, use HTTP blah 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 here. The first one here, when I start with star, then load data over internet. So this is just a node. When I put the star, data will not run it as a code. It's just a node. Are you following me? Every time you want to take a node, just put the star. Okay. It doesn't matter how many stars you have. As long as you start with the star, Stata will not treat it as a code. You can run it simply. Okay. So see on my window, load data over internet. It's just a node. But if you click this, use internet blah 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 here, it will be running as, and now loading data from the internet. And now you can see I have the data. Can you do that? Can you find this? You need to download this file first. For those who are using Stata now, can you follow me? Any problems?
Yeah.
Sir,
Where's
after we use, why I don't see anything here?
After running it, here, click here. After running it, you should be able to see the variable here on the data. Make sure that your computer have access to internet. Did you receive here? You have to look at this result window first. Is there any wrong? Anything wrong or not? Do you have it?
I saw it, sir, but I type in the command, not the do file.
No, then do it in the command. As I said, please always work on do file. So next time, just come and work on do file. Don't do it in the command window. Work with do file as mine. Here, if I want to clear it, if for instance I clear it, if I clear it, the data is gone. Okay. When the data is gone, if you work on command window, you have to come here and work it again and again. But if I work on do file, I just select all and click do. See, everything is running. So I have the data now. Following me? Class, again, always work with do file. Don't work directly on command window. Class, any problem with loading data from the internet?
Yeah, so when we want to load data, we use this command, right? We don't have to download data.
Right. We use the command use. And here is the directory or the where data store. The data is stored in this website. The idrc.uclc, blah, blah, blah. If you want to find, you just copy here and pass on the internet, on the browser to see where is this data. You see, it is here. This is the website. The data is here.
So if the data is not on the internet, we have to load manually, right?
Right. So here we assume that the data is on internet. If the data is on your PC, you have to load it from PC. I will tell you next, but make sure that now, can you guys now loading data on your data? You should be able to see this, the variable on your variable window. So by now, do you have any problem? Any problem with loading data from the internet? Yes or no?
No, champ. Mine is set file.
All right. When loading, you cannot load the data, so you cannot have data.
Yes, champ. And when I type the website, it like using command, it's also the same as in the win file.
Copy the whole thing. Copy the whole thing like mine. Do you have this file?
Yes, sir. Yes.
Okay, so copy and pass it. Copy and paste it. Don't type it. It's gonna probably there are some error with typing. You know, if you only one small mistake will give you the wrong address, wrong directory. Anyone else have problems? Can you load the data on this data now? Yes or no? Copy and paste this one, and make sure you have your PC have access to internet, because now we load data from the internet.
I think because we haven't clicked on the function execute, that's why the data does not load.
Class, after copy and paste, select it and click do. Here.
Yes, sir. That's why, sir. I found a solution now.
All right. So after you click do, class, look at the screen again. You can sell this data on your PC. Okay. So copy this again. Copy and pass it on the do file. Okay, pass it on the do file. And it's the note here say that sell data. And here you can see sell, and this is file name. Okay, command replace. If any existing data have the same name, it's gonna be replaced. So here you do not have directory. If you do sell and this is file name replace, it will store on your directory. In my case, it will store here. It will store in teaching material and stay there. So if I run this do, it's store here. So if I come back and have a look, here's the data. Following me? Okay.
Yes, sir. Found it now.
All right. So now zooming that, clear this again, class. Clear it. Follow me. Type clear data first. Now, what if you want to load data from your PC? What should you do? Okay, so if you want to load the data, there are two ways. The first way is if you already know your data directory or location like this, you go back to the do, okay, then you can load data. I put it as load data. So if I want to load this data and I know where it's stored, so I know it is in my directory, and now it's already in my directory, I simply set use, okay, and then just copy this file to put here. I want to use this data, the data that's stored on this, okay. So I click use and then I type clear. Clear here meaning that if there is any data on this now, I want to clear it first and then I use this data. Then I run it, it comes back. Follow me? This is only true if this file is stored in this directory only. Okay? If this file only stored in directory only. Follow me? So use meaning you use data, then use data name clear. Follow me? Questions? Can you follow me?
Clear, sir.
Okay. Now, let me clear this again. Now, assuming that I do not know where it's stored. Sorry, I don't know how to use coding. Okay. If you know how to code a command, like in do file, we just do, you can do it manually. You go to file, open, either open do file or open data. It's up to you. So normally you can open data here, open, okay. Then go to the location that you store your data. Then you click the data and then click open and come here again. And then for future you copy this command, but not with the dot here, okay? Not with the dot, you just copy this. And you can put it in your do file, and then next time you just load the data directly from this link. Okay, I type it again. This can be also be load the data. Follow me? So we start with, we don't know the command, so you can do it manually, then you just copy and paste it and store your do file. So next time, I clear first. I don't have to do it manually. You get what I mean? So this is how you load data from your PC. Is that all right? Questions?
No, sir.
All right. Next. Sorry, everyone. I want to close one window, but go on. All right, let's get back. Can you hear me? If you don't want to respond, just type in the chat so that I can see. All right, I assume that you can hear me. All right.
I'm sure we don't see the screen yet.
Not yet. Class, can you see the screen? I see the entire screen.
Not yet, like.
Not from me.
One more time. Can you see it now?
No, we cannot see it.
What happened now? Wait a minute. I share the entire screen. Can you see it?
No, teacher.
No,
Ah, what's wrong? Let
can
me
you
leave
close and say again? Close it and say it again.
Right, I did it multiple times. Let me live and join. Can you see it now? Still no, like.
No, just still blank.
What happens? Wait a minute. What's going on here?
We can see it now. Like,
Oh, you can see it now?
yes.
All right, good. So here, I hope you know how to load data from your PC now. We move next class. Don't have much time. We use the data that we just loading. Please load the data from your PC. All right. So what we are going to do next is to skip this, to do some descriptive statistics. You can spend some time to do some reading yourself, class. I just want to go some detail. All right. So when you have data, class, when you have data like this, if you look at your right window, you see the data is already on your data. So you can look at the data in detail by clicking data editor. Okay, you click data editors, then you see the data here. Okay, you see the data here. ID, male or female, sex, school type, program, score on reading, on writing, on math, on science, on social science. Is it an honor, award, whatsoever? Okay, so this is when you want to review your data. If you want to look at data in a full screen. Okay, so now let's do some descriptive analysis in which you just learn from the review statistic. We learn about what? Central tendency, variance, standard deviations, and so on. But we are going to do some review on this. All right. So, sorry, we are going to compute it using data. Okay. So now we already have data. So what we are going to do now, first of all, class, I'm going to be very quick to the point that I want to have a look. So here, first you can describe your data to know how many data you have. Okay. So you can go to your do file. All right. Then first I take a note. Describe data. Okay. Describe data. Just type describe. That's it. Okay. Describe and then click do. And here it tells you what is going on. You have 200 observation. You have 13 variable. Okay, and this is in detail the nature of the data, but you don't have to care because you don't know that yet. But here it tells you how many observation and how many variable. Did you get the result by writing describe?
Could you show that again?
Here, just simply type describe, write describe. So describe command tell you everything about your data. Follow me, class. Can you get the result? So here, observation 200, variable 13 variable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. See? Correct. Class, did you get the result? Yes or no? Yep.
We got this. What does size mean here?
Size here, something you don't have to understand for now. I will tell you later. Okay. So this is the size here is more on about your data side. But now it's okay. Just ignore it first, okay? So what you need to understand by the nature of data is observation and variable. All right. So next, we are going to describe to do some descriptive statistics for this variable. All right. So now, for this, I mean, for here, if you look at this data, everyone, if you look at this data, again, you see that there are some numerical variable, some categorical variable. So says program. Okay. So for categorical variable, you can look at its code. Okay. So you can look at its code. You can, here I copy from this. All right. You can inspect the value of variable. So here, I can have a look at code book of gender. So I type, you can type it again, code book gender. And the color, so that code book is the code, is the command, gender is the variable. Okay. Then I click the runs. Okay. When I click runs, gender is not found, sorry. That in our data, there is no gender variable. What is that? It's female. Okay. So code book female. So it tells us that 0 is for male, 1 is for female. Follow me? Here, when you want to look at categorical variable, you can have gender, you can have sex based on the variable on your PC here, on your data here. Sex, even school type as well. Okay, school type. Then run it again. School type not found, meaning that I type it wrong. So school type here is SCH type, no E. Okay, so like this. Right. So I should know for gender, for the sex, social economic status, school type, public or private. Can you follow me?
Yes, sir.
Okay. Any questions up to now? Step by step, you have about 13 weeks to go. So by the end of the day, you should familiar yourself with this. It's more on practice. If you practice more, you familiar more. Any problem, class? Any questions? Okay. So if you want to take note on that front line, you can do it like this. The green highlight tells you that this is just a note. Okay. And this is command or code. But if you want to take note on the same line, if you want to take note on the same line, you can do it as well, but with 2 slashes. Okay. So with 2 slashes, say this is code book. So it treated as the green, yellow here as the note. Okay. Here I want to take note on the same line. So I can delete this. and I can't understand how this is code book. Okay, I run it again. If you want to test it, it's the same. Okay, so I have the node on the same line, not in different line now. Follow me? Is everything okay? How is it, everyone? Can you follow me?
Good, sir.
Okay, good. So let's move next. All right. So our next is to summarizing continuous variable. Okay, summarizing continuous variable. So before summarizing continuous variable, you should know what are the numerical or continuous variable, right? So based on this data, you can see that read, write, math, science, social science, award, or CID are numerical variable, not categorical variable. So with that, we can follow this. We can just, for instance, I copy here, summarize variable, right? Summarizing continuous variable, then summarize read and math. And here it is. Okay, I only summarize read and math. So for continuous variable class, with the summarize, you can have multiple variable. For instance, I can have read, write, math, social science. So I just don't want to type it, I just click it, and then I copy this and put it on my do file. All right. To summarize it, every here. So I have 5 numerical variable. Follow me? So if you don't want to manually type your variable name class, come here and then click it. You can see arrow here. When you click it, it appears on the command window and copy, and you can pass it back to your do file. Okay, then you wrote summarize. Follow me?
Yes, teacher.
And here, if you look at the result, you see what? Observation, how many n? Mean, that we just discussed earlier. Standard deviation. Okay, they are all here. Okay, so you know the mean score of it is about 52, and standard deviation is 10. So this is the variation, this is the mean. Okay, that's how it works. If you want the detail, for instance, if you want the detail, you can say, for instance, if you want the other variable as well, you can say tab state. All right, and then you copy this variable. Okay, class state, meaning that statistics, and then put what statistic that you want. I want mean, I want n. N is the number of observation. I want mean. I want standard deviations. I want median. I want CV, coefficient variations. I want mean. I want max. Okay, so this something that we just started. Oh, it unknowns standard deviations. So then what should it be? SD? I try to find abbreviation first. Does it work? Yes. Okay, so this is what we studied earlier. Okay, CV here. The how far is it from mean in percentage? It's small. Can you follow me?
Yes, teacher.
Okay, so this is what we reviewed earlier. You have ends, you have mean, you have standard deviations, and this is P50, median meaning the middle, right? So it is P50. In Stata, it appears as P50, it is median, the middle. So you can compare middle and mid. Not very much difference. Coefficients, variation, it means that on average, it is about almost 20% from mean. For the right score, it's about 70% from mean. From math score, it's about 17% from mean. Minimum 28, maximum 76 for mean, right or not. Okay. Can you follow me, class, with the summary of numerical or categorical variable? You can either use summary or you can follow me as tab state and then specify your variable here. Now I want to add more variable, so I add more. Okay, and type variable read wrong. See, so I just edit it and work on it. So see, working on do file is very fast. It's very fast. If you work on command window, you have to do it again and again. So do file is faster and safer. So here I have the descriptive statistic. But normally is enough, summary is enough. This table is enough. Mean, standard deviation, min max is more than enough. You don't have to calculate CV, but if you want CV, you just type CV like this. Okay. SD means standard deviation, CV means coefficients of variations. Are you following me, everyone? Can you follow me?
Yes, lecturer.
Good. Kim Hua, I'm sorry, you don't have Stata yet.
I actually installed it, like I got it now.
Oh, good. So you are using Mac. So share with class. If you don't have the Stata installed on your Mac, you can ask Kim Hua.
Yeah, actually I got it lecturer. Yeah, he told me how to do.
Oh, good. Excellent. So everyone, can you follow me? So now what I want to try to do, as I said, is apply econometrics. And every time we talk about statistics or mathematics, I always try to connect it with application. So earlier we discussed about review statistics, mean, median, coefficient, and so on. Now I connect it with application. So what you have to do now is try to interpret this. The average score of rate, the standard deviation of rate, the median of rate, the coefficient variation of rate, minimum and maximum, you see? So we have already reviewed it, how you already know mathematics behind it, how to calculate mean, how to calculate standard deviation, how to get median, how to calculate coefficient of variation, and now Stata quickly do it for you, and now you simply need how to interpret it. Any questions? Step by step, class. Today is the first time you guys exposing to Stata, so you guys are expected to familiar yourself with Stata from time to time. The more you practice, the more you familiar with the code. Just like an IT specialist or data scientist. Questions?
How to view in graphics? Could you share something?
Next week, we're going to do it on graph visualization. We call it visualization. Okay. So for today, it's just an introduction to get yourself familiar with interface and to do some descriptive statistics with continuous variable and categorical variable. Next week, we do some sort of visualizations. Okay, David, be patient, or you can study it yourself, David. If you have time and you love how to do it, here, this slide, as I share with you, this is very comprehensive, and you can find how to do visualization here. using the data that we have. Okay, just follow this if you have time. You can start it first, and then next week come with me, and then you can ask questions. Okay, I am fine if you go first. Don't worry. All right, is that clear for everyone? Questions? Step by step. So today you learn a few code. The most important thing is that always work with do for. Okay, and I introduce you to some code: clear, use, describe, summarize. If you want to learn more and more coding, look at the slide. Here I only pick up some commonly used code and the code that you are going to use. Questions?
No question, sir.
All right, next. Now we go to the wait a minute. All right. In addition to a simple summary class, you can also do it summary in detail. So just simply copy this, summarize it, and then you pass it down, and then you give it a comma and then type detail. This is called options. Okay, detail. Then you can run it. But now it provides not simply just what you get earlier. With this score, you get first percent, 5%, 20%, 50% in detail. Then you can have sum of the wage. You can have mean, standard deviation, variance, skewness here. I did not tell you. And here, at least you see the variance, standard deviation, and the other more. Here, just, add the detail. Summarize, variable, and then comma, detail. You get the detail. Follow me? Is it okay? I hope your brain is not burning with this hand-on exercise, unlike the statistic review. Is that okay?
Yes, lecturer.
Okay. Now we move next to descriptive statistics for categorical variable. For categorical variable class, it is not the same as continuous or numerical. For numerical and categorical and continuous variable, we analyze central tendency, we analyze variability. But for the categorical variable, we simply analyze frequency. Okay, and unlike continuous variable, you cannot analyze multiple variables at the same time. You cannot. So now, oh, by the way, class, for instance, with the summary, if you, for instance, when you start the first time and you don't know the code, the command, you can start with manual click first. Okay, you go to statistics. I forgot to tell you. You can go to statistics and then you click summary, and then here's summary and descriptive statistic. And then you click summary statistic. Follow me. If you don't know the code, assuming it first time you started, you don't know the code, you can do it manually first. And then summary statistic, okay? Then just select the variable that you want to analyze. Read, write, okay? Then okay. And then after that, you can copy this command and put in your do file if you first time started. So again, remember, if you don't remember the code, don't worry, you can start it by manual click. Okay, this is just a quick reminder that you don't have to do it coding every time. If you don't know it, you can do it manually first and then copy and pass on your do file. All right. So what I want to tell you next is descriptive analysis for categorical variable. So here, as you can see, copy this. We want to run frequency for, says here, it means social economic status. Okay, so here I copy it, pass it on my do file. Okay, do I have variable says? Yes, it is here. Right. So earlier we described the code book of says. Now we run the frequency. And here, as you can see, among 200 respondents, 47 is low socioeconomic status, 95 middle socioeconomic status, 58 high socioeconomic status. And this is in terms of proportions or percentage. Following me? Can you do that? Tabulate says. Or tab is only enough. Tab is the short form of tabulate. Either tabulate or tab. The same. Any problems? Can you follow me?
Yes, sure.
Okay. So here, as you can see, says here is show what we call label. What do I mean by label, class? Here, this is called name, variable name, and this is label. Oh, sorry, this is yes, this is label. It's label. So says here they have low, medium, and high. If you do not show, do it like this. Here, you remove label. I copy it, pass it here again. Okay, so just have says no label. If no label, it will not tell you low, medium, or high, but it tell you 1, 2, 3. But the problem here, you do not know what does that mean. So it's better to not remove label. Not to remove label. Okay. So again, for categorical variable, you cannot run it multiple at the same time. For summary, you can have multiple at the same time, but for categorical variable, you can't. Okay, you can't. You cannot do it. But for categorical variable, you can run what we call two-way. You want to cross tab. Okay, you want to cross tab. For instance, okay, you want to cross tab between sex and female, for instance. Okay, I want to know how many male or female in low sex or high sex. Okay, so to do that, tab. Okay, tab again. And then says you want to cross tab with what? With female. Our variable name is female, right? So this is I cross tab between sex and female. And here you can see this is 2 by 2 table. Okay, low, medium, high, male, female. Follow me? So this is what we call cross tabulation. Only work for categorical variable. Follow me?
So what if we want to show percentage in that as well?
Okay, if you want the percentage, the question is percentage in terms of row, in terms of total, or in terms of column. Okay, I copy here. If I want percentage in terms of row, okay, comma, type row. You got this. So this is percentage in terms of row, meaning that by sex. You see? So we have among total respondents, 30% of low sex are male, 68% is female by row. You have to be sure yourself whether you want percentage by row or by column. If it is by column, copy it again, but change from row to column. Then you will get this. This is now by column. Earlier by row, now by column. Okay? If by total, now you can say by cell. Right? This is total. Follow me? So you have 3 options by percentage. either by row, by column, or by total. You have to choose it yourself. Following me? Questions? Did you get the same result as mine? So I say again, class, for continuous variable, you can do summarize multiple variable at the same time. For categorical variable, you can't do it multiple at the same time. Okay, but you can cross tab between two variables. And if you want percentage, you have to ask yourself whether you want percentage in terms of gender or you want percentage in terms of sex or percentage in total. Ask yourself first. Okay, then you can use the options here, either command row, command column, or command cell. Okay, so let me tell you next. If you do not want frequency, you only want percentage, you can, here is the percentage in terms of total, and you can say no frequency, no free. And you run it, you get only percentage. Just say no frequency. I did not introduce you to the standard command of coding of Stata yet, but because today just the first introductions. Okay. Can you follow me? So today you learn a little bit about introduction to Stata interface. You learn about loading your data, describe your data, do some computation for descriptive statistic for continuous variable and descriptive variable. Questions? We have about 1 minute to go.
Lecturer, can you send us the data just for us to practice?
The data?
Yes, the
or
data
what?
that you have right now. Yes.
Oh, you can, as I said, look at this slide. You can load it from the internet, Kim Hua. The data is in this slide. You can load it from the internet. It is from here. Slide 25. Kim Hua.
Ah.
So you can load it from the internet.
Okay, lecturer. Okay.
Okay. But if you still want data and do file, I can share with you in here. As I said, everyone, for those who have not installed your data yet, if you closely follow this slide, you get it. If you have any question, you can come and ask me next time. Is that okay, Kim Hua?
Yes, lecturer. That's okay.
Okay. Okay. Question, everyone? So silent. What's going on?
Sure. SPS and Stata are the same, right?
No. What do you mean by the same? They both are statistical application or software. But SPS is, from my perspective, it's good for data entry. It's good for you know, for those who are in social science. When I say social science, I mean that there are no fields like as sociology, but for economists, we tend to use data more than SPS. Actually, in SPS, you can, very similar to data, you have you also can do the syntax, but that is not comprehensive as data. So just a different software. But be honest, SPS is almost outdated in terms of data analysis, from my perspective. Do we answer your question, David?
Yes. One more question. So
Yep.
in Stata, the variable, the denotation of it is follow the same rule, or we can just put the variable name by ourselves?
Just follow just yourself. But as you know, in Stata is case sensitive. Remember, always use lowercase. That's why if you look at our data here, all are always lowercase. Okay, always all lowercase. And again, data does not allow space or variable name. You cannot say, as I told you earlier, G of schooling, you cannot have space. You need to use underscore or dot. Okay. Class? Questions before we close today's sessions? No? All right, class. That is all for today's session. Next week, we will continue statistic review and continue our introduction to data on week 4. We are going to start econometrics. All right. So I see you guys next week. But again, don't forget to read the slide, to review the slide, introduction to data and to detail, so that you can get more information. Because of the limited time, I only pick up some of the main key to introduce to you guys. But there are many details that I skipped from the slide. As you can see, the slide here, there are 131. And now I only touch only some slide. So again, if you have time, if you are interested to learn more, don't forget to review this slide. That is all for today, class. I do not have homework for this week, but remember, you have a homework to be submitted by 16 October. All right. Safe and take care. I see you next week. Bye-bye.
Hello, Lex.
Yep.
So before we end the class, I just want to let you know that you have added 2 students that are not belong to our class. So can you remove them out to avoid confusion?
Yes. Can you tell me the name of the student? Can you telegram me? Delia?
I'll text you in Microsoft Teams. I'll text you.
Okay. Thank you. Because the name here is the class here is just the duplicate from the existing class that created by the head of the program. So I do not know whether they are in or out. Thank you so much for the information, Delia. Thank you. Thank you, everyone. I see you next week. Bye-bye.
Goodbye, teacher.
Bye-bye.
Bye-bye, Lex.
Bye, teacher.
Bye,
Everyone,
lecturer.
next time is your turn to talk, okay?